Have you ever wondered just how much of the accepted wisdom out there is just plain wrong? How many things are we told that we just accept as fact without questioning? I've always been a bit of a skeptic, especially when it comes to advice where the source has a financial motive. Now, a skeptic is not a person who has no beliefs, just someone who won't simply accept things without some level of questioning and reflection. I decided that it would be fun to put together a video series that questions the conventional wisdom in a bunch of areas. I've already done a number of them discussing the nature of money, and I may do some of those here, but let's broaden the field somewhat. After all, money is only a small part of life, and all of life should be explored. Let's start the series by questioning the advice that we're generally given about protein consumption. Why is this such an important question in the first place? Well, first of all, there's cost. Traditional sources of protein are quite expensive. Anyone who has taken a trip to the supermarket lately would have a difficult time arguing otherwise. Meat has gotten very expensive, and it's getting more expensive every day. In many parts of the world, it's very difficult to afford, and it's heading in that direction in Western economies too. People who eat a lot of meat now must consider the possibility that at some point in their lives, they may be forced to cut back considerably for economic reasons. The second reason is health. I've read a considerable amount of medical journal articles on the subject of nutrition over the past couple of years. One of the topics that's been of particular interest has been the statistical link that's been drawn between excess protein consumption and what are now being called the diseases of affluence. These are the diseases that tend not to be present in poorer economies. I can't go into detail in this video, so perhaps it's the subject for another video. But it has to do with the waste products generated when excess protein is metabolized, and the fact that protein stimulates the growth of all tissues, some of which we prefer not to grow. A third reason is sustainability. The production of protein-rich food simply requires more resources than the production of other foods. Again, this is probably a good topic for another video, but calorie for calorie, the production of protein-rich food requires tremendous amounts of water, land, disposal of waste products, and consumption of fossil fuel. All of this contributes to the monetary cost, which I've already discussed, but it also has an environmental cost. Lastly, we have humane considerations. If you've ever seen the conditions in which the animals involved in the industrial food chain are kept, you would have a hard time not feeling empathy for those creatures. Factory farming is a pretty brutal industry. All of these reasons have led me to question what levels of protein are really needed for a person to thrive. What I've found is that medical research has come to a considerably different conclusion about the amount of protein that's necessary for a person to consume, and it's a much smaller amount than what we hear suggested by the U.S. Department of Agriculture and other official sources. I will not provide an overview of all of the medical research because there's just too much of it for that to be practical in a 10-minute video. What I will do is present to you a thought experiment that I have done and the results of a personal dietary experiment that I conducted afterwards. Let's start with the thought experiment. Here I'm showing you a chart of the average weight of male children in the U.S. as a function of age in the year 2000. The data came directly from a study put together by the Centers for Disease Control. What we can see is that the average weight increases very quickly in the first couple of years of life, then moderately quickly up to age 16, and then the rate of growth slows down markedly. For the first 2 years of the life of a baby, the weight increases at an annual rate of 104%, which is an amazing rate of growth. From age 2 to age 12, the weight increases by 14% per year. From 12 to 16, a boy's weight increases by about 10% per year. Then from age 16 to 19, the rate of weight gain decreases to 2% per year. The important thing to notice here is that the most rapid phase of growth is not from age 12 to 16, which are typically referred to as the growth spurt years, but from birth to age 2. Why is this important? Well, we're told that protein is a critical building block for tissue growth. And where do babies get their protein? Are they eating big hunks of chicken and steak? No. Most of their calories, for the first year at least, comes from either mother's milk or baby formula. Let's take a look at human breast milk and baby formula and compare it against a bunch of other foods in terms of protein content. Here's a summary of a number of different sources of calories. Notice that 6% of the calories in human breast milk comes from protein, and the makers of baby formula come pretty close to this amount with 8.8% of calories coming from protein. So we can see that surprisingly little protein is actually needed during the most rapid phase of human growth. A baby can double in weight many times over without consuming more than 9% of its calories in the form of protein. One has to wonder why the U.S. Department of Agriculture recommends a diet as high as 35% protein for adults, who for the most part are simply maintaining their weight. I've tabulated a number of other foods here for your reference. Let's start by comparing cow's milk to human breast milk. More than 25% of cow's milk comes from protein. This is a startling difference. But then calves need a higher percentage of protein than human babies because calves will double their weight every 50 days or so, whereas with a human baby it takes close to a year to double in weight. The faster doubling time for a calf requires a higher protein content in the diet. Now, scan down the list to look for foods with the highest protein contents. They're all at the bottom. Not surprisingly, we see red meat, fish, and chicken breast in the list with more than 40% of their calories coming from protein. Why isn't red meat the highest? Well, it's because red meat has a much higher percentage of calories coming from fat than does a chicken breast. Now, we are told that these foods should be consumed for protein because we need the protein for tissue growth and repair. And sure, some protein is required, no doubt, but if a growth rate of 104% per year can be sustained with a protein content of 6 to 9%, as is found in breast milk or baby formula, then wouldn't it suggest that 40% or more might be unnecessary? But where's the limit? Suppose that of the 40% or more of calories that come from protein, less than 9% is actually used for maintenance of muscle and tissue. What does the body do with the rest of it? Well, as I mentioned before, that's a topic for another video. But suffice it to say that it goes towards other types of growth that aren't necessarily desirable, or the types of tissues that we want to have growing. What is the most surprising about this chart are the number of plant foods which exceed human breast milk and baby formula in terms of protein content. Even the cheapest of all of the foods, white rice, corn, and potatoes, have more protein than what is required during the most rapid phase of human development. This is really encouraging news because it suggests that if we can convince ourselves that we don't need anywhere near the up to 35% protein suggested by the USDA, it can assure us that we can live or even thrive on a very modest food budget. But even if we need more protein, notice that there are many other cheap foods with significantly higher protein levels than are found in white rice, corn, and potatoes. Other grains, such as oats, aren't as cheap as rice, but certainly cheaper than meat, poultry, and fish. And look how much protein oats contain. They're up there at 17%. And lentils, which are just one of many legumes, have more than 30% of their calories from protein, close to the levels found in beef. Spinach is an interesting one because it's a leafy green, which is about half protein. You can't get a significant amount of your daily calories from spinach, but I thought I'd put it up there on the list because it's curious just how much protein it contains. Now, this thought experiment doesn't prove anything. All it does is provide some evidence that maybe what we're being told is wrong. But this was enough evidence to lead me to try a personal experiment. The outcome of this experiment has convinced me of the right answer. I'll provide you with some details, but I'll let you reach your own conclusions. I asked myself a question. Will muscles atrophy if all animal-based products were eliminated from the diet for a period of 6 months? 6 months seemed to me to be an adequate period of time. Certainly if cutting back on protein was going to have an impact on musculature, it would show in 6 months' time. So I cut out the very high protein containing foods such as fish, poultry, and red meat, but I also cut out milk and eggs just to be sure. Now, I also needed to note that I cut out low protein but high fat foods such as cheese and butter. And my reasoning went like this. A potato may be 10% protein by calories, but a potato covered with butter or cheese might be less than 5% protein when the extra calories are considered. High calorie but nutrient poor foods might taste great, but they'll simply dilute the nutrients available in other foods. For a similar reason, I cut out refined sugars and very high fat containing foods such as nuts. Truth be told, I was quite nervous going into this experiment. I'm a very athletic person and I have a good build. I was legitimately concerned that I'd lose the physical appearance that I had worked so hard to attain. But I did have enough evidence to suggest that I'd be happy with the outcome, and so I gave it a try. Surprisingly, it was not very difficult to adapt to the lifestyle. Cravings for meat were minimal because I was constantly stuffed. And this was counterintuitive. It actually took some effort to eat the volume of food that it took to get between 2,500 and 3,000 calories a day when fat and refined sugars were eliminated. This large volume of food had the effect of making me feel full most of the time. And the outcome of the experiment? It was better than I had hoped. Not only did the muscle not disappear, but it had become much better defined. I lost quite a bit of body fat. In addition, I felt like I had much more energy to engage in the sports that I like. My performance increased. I also saved quite a bit on my food bills each week. The only downside was that my change in diet pissed a bunch of people off. I never suggested to anyone else that they should do the same, but for some reason, people take it as a value judgment when you do something differently than what they do, even if you're not vocal about it. Oh well, people will be people. The thought experiment was so successful that I've kept it going. The outcome has been compelling enough to reveal to me what I believe to be the truth, and I'd encourage you to do some exploring on your own to convince you one way or the other. I thought I'd share all of this with you because protein need is an important question, and unfortunately, I think it's just one of the many lies that we're told.